Okay, ingress, everybody's favorite subject. We typically think about ingress as an upstream problem, right? Now, the reality is there is a lot of over-the-air energy that is just bouncing around in the air. Has anyone ever taken a spectrum analyzer and a really good antenna and just walked outside and waved it around? Have I ever done that? Besides Brad? Yeah, exactly. Yeah, and there's a lot of energy out there, right? I did this once in Miami. I took a really nice Rhodian Swartz portable spectrum analyzer and a nice directional antenna, and I looked at all of the energy that was off air, and I wanted to run back to my hotel and put a tinfoil hat on, because there's so much energy out there on the air, we don't really realize it because you can't see it, but it's everything from VHF to over-the-air television and UHF, and VHF and FM radio, and especially in major metropolitan markets. And I use Miami as an example because there's a large Latin American population there too. So almost everything that's over the air is broadcast twice, once in English and once in Spanish. So depending on your market, the amount of over-the-air energy can vary, but most major metropolitan markets with large populations have a ton of over-the-air energy. All of your cellular communications and LTE and GSM, all your over-the-air high-definition television broadcast, all your FM radio, all of that stuff is out there bouncing around in the air. Now, with the spectrum reuse rules that the FCC has, they're licensed to use those spectrums, and so are we. So the difference is our system is supposed to be a closed system, meaning we can keep all of that stuff out and keep all of our signals in so that we don't unintentionally interfere with each other. Now, both those systems and us can become unintentional radiators. If we're operating outside of our proposed rules or the FCC's proposed rules, we can unintentionally interfere with their services. Likewise, if we have a shielding defect in our system, it is no longer closed, and any of these over-the-air energies can then get into our system. And the system, the cable and the amplifiers don't know one signal from another. They just know there's energy in this frequency at this amplitude, and it gets transmitted through our system in either the upstream or the downstream. So FM radio is a great example. My first system that I worked cable television was an HRC system, and I believe it was channel 6 that had a audio carrier in the FM band. So in Youngstown, Ohio, there's a national public radio station on 88.5, and I believe that was the HRC audio frequency for channel 6. So whenever we had a radial crack or a shielding defect in the plant, you could turn your TV to channel 6, watch C-SPAN or whatever it was on there, but listen to Youngstown State Radio, because the over-the-air energy was getting into the system, being transmitted through the cable and demodulated by the television's audio. It doesn't know any different. The televisions and cable boxes don't know one energy source from another. They just know there's energy there. So it was actually kind of cool. If you like to watch C-SPAN and listen to the radio at the same time, we could do that for you. Just loosen the connector at the tap and there you have it. But that's the commonality that we have with all of these other over-the-air providers, is that we share the same frequencies. Now, the good news is that we can identify these and localize them using some of these downstream full band capture services. Ingress, we've identified, here's FM in here, so wideband in here, you've got the LTE. Now, we have to use this as just part of our intelligence gathering process. So for instance, in this example down here, you don't see that energy at a level high enough to peak over the carriers, right? That doesn't mean it's not there. It may be at a lower level than the actual transmitted energy inside of our system, but it will show up as a signal quality, possibly an MER issue on a channel, if that energy is there, even if you don't see it in the spectrum. So just because you don't see it doesn't mean it's not there. Okay, these other ones are really easy to detect because they're intruding into the system and being broadcast at a higher amplitude than our internal channels are. So ingress is a big problem even in the downstream, and I would argue it's becoming more and more of a problem as other providers are getting into the over-the-air space, particularly cellular communications, right? We've got cellular providers at 750, 770, 860, now all the way down into the 500 and 600 megahertz range. There's LTE over-the-air licensed broadcast. So we have to pay particular attention to the shielding integrity of our systems to keep this stuff out. Okay, suckouts. We mentioned these a little bit briefly before, but these are just a half period of a really long-standing wave. So if you were to extend this out, it would probably extend beyond the passband of what we can see, but they typically manifest themselves as, in severe cases, really deep, very periodic shaped short reflections. So these are in small devices, typically taps, sometimes directional couplers and splitters, a lot of line passives, sometimes in the house, but most oftentimes there's water intrusion or moisture migration into a hardline passive device that manifests itself as a suck out. And sometimes these will move too, right? You'll see them vary in frequency a little bit over time if you watch them long enough. But again, when you see a suck out, often most times you'll see multiple devices in a location in your intelligence tools that all have the same symptoms, and then you can track those back up the architecture upstream to a least common ancestor. I would start looking at a passive. Okay, these are a little less common, but they're still out there. Over the years, our services have evolved where we used to have positive and negative filters, and we used to manage customer services with the use of traps. So in my first system, I think we had an expanded basic trap where if customers had only basic services, which was like channel 2 through 13, you would have to go out and install a expanded basic trap to prevent those signals from passing back then to analog televisions. And that's how the services were managed. Amazingly, some of these filters and video traps are still out there. You know, customers been hooked up and not, purchased our service for years. Who knows? Somebody bought one on eBay and said, you'll get Cinemax for free. So they bought this thing and hooked it up, and who knows? There's all kinds of different ways where these things could find themselves connected to customer devices. However, again, the full band capture device will just represent what energy is present on the input of it. Without regard to what and where, it's up to us to look at the signatures and understand what the causes are.